Hello YouTube. So this video is going to continue on the last one where I talked about my 3 robotics projects. And in this video what we're going to do is we are going to organize all the parts for each robot in their respective boxes so that I know which parts goes to which robot, because how it's working a lot now is I'm busy a lot of the times, so I just order parts whenever I think I need them and they just pile up, and I don't know which parts go to which robot and what they're supposed to do for each one. So we are going to try to solve that problem today. First, let's take a look at the small robot, since I don't think it has very many parts which go to it. Of course, there's everything in that robot. And then it has batteries, so those are its batteries. And you could see it has these little leads. It's going to need some here and some on these positional control things. What it needs are these male to female connectors, so I could connect the female one on this part and the male one could go to a microcontroller. And I'm going to have to order a lot more of these, but I think for now I'm just going to put all of them that I have with this robot. Also note, quite a few of them are on that one right there, but I'm going to have to basically order more for all of these robots, but all the ones I have right now are going to go with this one. Just because I'm going to finish this one first and I'm going to need these first, so why not? Except for these are actually male to male. I don't think I need those. Yeah, these ones definitely go with that box. This is a box of just random assorted parts, and you can see there's servos. None of these projects I'm doing right now have servos. I am thinking about having another robot which uses servos, but that would be other than the ones I'm working on right now. Super glue. I did use a lot of super glue on this robot just to connect this in place, so if this goes anywhere, I guess it goes here. There's really not that much. I guess we could have some hot glue in there. And zip ties. You can see these wires right here, they go with holes, and I'm going to zip tie them in place eventually. So I'm going to put some zip ties in this box. And it's very exciting YouTube content, putting zip ties in a box. Oh wow. These ones are female to male connectors, even though they're the same colors as those male to male ones, they are different. So these do go in the box. I don't think I'm going to go through every single connector just because I have a lot of them, but that's about all I really need to do. So here's another red one. The red could be used for power on those rotary encoders, that's what they're called. Green one, there's a green one already there, so maybe that could be ground or data output depending on what other connectors we have. It's a male to male connector. That one doesn't even, like some of those connectors that I have, these wires are broken, which is not that good. Oh, also this Velcro, I'm using Velcro on that one. And that looks to be if I can see. Yeah, so here's a brown one and a red one, but the red one is broken. Still goes in there. Broken male-to-male connector. Okay, so that one, I think that's about it for this small robot. Also, the robot's so small it could fit in there. Alright, so everything that has to do with the small robot is in that box. If I order more stuff online for the small robot, it will also go in that box with the rest of it. Moving on now, this is probably going to be the most amount of stuff, is this medium robot. Looking in here, we already have a bunch of wheels. We have the new wheels and we have the old wheels. The old wheels have holes in them and the new wheels don't, yet at least, and they also have their tags. So also in here is these servo connectors. None of these robots use servos. Yet, at least. If it has arms for any one of them, they might use servos. But I am going to do some projects with servos, so let's go ahead and go in here. This could be the servo robot box, I guess. So what's in here? There's bolts and some tools and scotch tape. We don't really need that in there. These are like electrical stickers for line voltage. This is a gear which I made up like a year ago, which does not go on any of these robots, so that goes out. These are boxes that are not useful or not useful. And these are clamps. These are battery clamps. I used to use these on these robots, but I'm going to take them out. But for the purposes of what we're doing, they're going to stay in the box. Alright, so let's actually put stuff back in here. Also, there's a bunch of bolts and stuff that goes somewhere with this robot. So let's put these wheels back in place. Those are the wheels we are not going to use. The ones we are going to use. This is actually taking up quite a bit of space. So if I really need to, I'll take out the ones that we're not going to use. Yeah, so these could fit in here. And when we replace the wheels, we can get out those. And I still have the old ones, just in case I find something to do with them, maybe. They are there. Also, one thing that I'm going to do with this robot is I'm going to replace all these relays with motor controllers. These are proper motor controllers that actually control the speed instead of just turning it on and off. They look like this. I have 4 of them, but they are still in anti-static bags, so they're going to go in here. Also, one thing to note, I'm going to use more of these. Well, if these work out well for this robot, I'm going to buy more of these and use them on this robot. If not, we're going to have to think of something else. Because, of course, they use drill motors. Both of them do. So, these are in anti-static bags. There are 4 of them for 4 motors on this robot. Then we have these power distribution connectors. I'm going to redo all the power distribution on there. The wires I'm currently using are 2 then. I'm going to get these Zicker 12 gauge wires, and hopefully that will make power flowing better. So here's the negative wire. It's automotive wire. There's terminal blocks, a piece of electrical plate, and a fuse holder. Also in here I have some relevant stuff. I have 25 amp fuse. It might be a little too high of amperage, but it fits in there, so I can use it until I get more properly rated fuses. Also, I have this wire. This is 12 gauge red auto wire, the positive wire. I just put in a negative one a while ago. We have some bolts. There are 1/4-inch bolts. Yes. These are 1/4-inch hex nuts. Yes. Okay, 1/4-inch hex nuts. Just from looking at them, while both of these robots have 1/4-inch hex nuts, I think this robot is going to end up needing more of them, so I'm going to put these with this one. For 1/4-inch washers, again, both of them have them, but I think all of the ones that this one is going to need are already on it. This one is going to need quite a few more, so they're going to go with this one. Also, another one of these pieces of plastic. Well, I have 3 of them. I did not know that. To connect the new wheels to the new wheel hubs, which will be 3D printed, I will use these bolts. Also, I believe I have more stuff for this robot. Wait a minute, hold on. Look at this. These are more female to male connectors. And let that one to go. Looking in here, at this point it's mostly just servo motors. And ignore the PCBs. So the drill. It's a 5/16 inch drill bit. This should go with tools. It shouldn't even be in there. And we have more tools. The solder bulb. Alright then. Oh, also, these are connectors we might need to connect to the battery. They go in there. Again, that robot might need some of these, but if I use them for this robot, then I could just get more later. Looking at my desk, more servo motors. Another one of these. A battery holder. Wow, I didn't know I had that many of these. We might be able to actually finish that robot sometime soon, rather than later. Oh, this is a battery holder for 8 AA batteries. You can see this robot is going to be powered by these Energizer rechargeable batteries. For this one, I still have a bunch of drill batteries, but I think those are nickel cadmium batteries, and those are not as good as these nickel metal hydride batteries. Lithium batteries are better than both of them, but lithium batteries need a bunch of regulatory circuit voltage. And, well, I might do that for this robot, make a lithium battery, because I do have the correct circuits to do that. I actually bought a battery monitoring system online, but I still have a bunch of these, and I could just buy more of those and make a nickel metal hydride battery. For this robot, it could be, if I use this one, I'll get 9 volts, which is perfect basically, because what I can do is I could just make a bunch of these 9-volt batteries, wire them in series, and then wire those in parallel to get 18 volts. And this is about, what are these ones? They're several amp hours. Oh yes, they're, can you focus it? Well, they're 2300 milliamp hours. So about 2 amp hours for those batteries. I could, for example, wire 2 of them in series and then make another pack of 2, and that will give me 4 amp hours, which is quite a bit better considering that the normal drill batteries, well, of course, they are much bigger than this one is, and they're only about 1 amp hour each. So it's about twice the capacity at half the size, if you want to think about it that way. So, and I do have a bunch of these somewhere, so these are going to go for that robot, and that robot will have a nickel metal hydride battery. Moving the Subway drink aside, We have not too much. Oh, this is a piece of plexiglass that came with the kit for that robot, so there it goes. Then we have heat shrink tubing, a soldering stand that I made. Not too much. Oh, also there's a Raspberry Pi. I need to make an entire video about this, but this is going to go on that wheeled robot eventually for computer vision, stuff like that. But right now, since that's kind of far ahead, I'll just leave it here. There's electrical tape, capacitor, stuff like that. This stuff's kind of a little too general to go for a specific robot. Then of course we have solder, and we have a bunch of these. I guess we could talk about these. These are bolts, well, screw things, 10/32 set screws, which are used to secure down the chuck of a drill when you want to convert it into a drive motor. You see, here's ones for this robot. I could see I screwed it down here. All the motors on that robot have, because both of these use them, all of them have them on that robot. All of them have them on this robot too, but I'm going to probably have to replace one of the motors, and I'm still going to have more later. So I think all of these will be best served by the other robot. Looking at the rest of the stuff, there is, oh look, more of these wires. Well, so we could probably actually finish this. Well, aside from the Arduino needs to be soldered, and I don't have the header pins, but that is what I need to buy, and then that robot's essentially done, at least mechanically. The programming should be easy too, since it's just an Arduino and it's not doing all too much. Speaking of Arduinos, here's another one. This robot already has an Arduino, the Arduino Mini. That one has an Arduino Mega. This one doesn't have any Arduino at all, so you might think, oh, I could put this one on there. But actually, I think I'm just going to buy another Arduino Mega or more of these mini ones, because this is going to have some weird electronics on it. Since it's so complicated, I think what I'm going to do is I'm going to connect 2 of these motors to one Arduino and 2 to another one. So all of the low-level commands can be handled through those 2 Arduinos, and then they'll be connected to a central Arduino, which will just tell it, move the leg forward 4 centimeters, and it will compute all the angles it has to move and how it will move the motor in relation so that the leg steps forward 4 centimeters, for example. Something like that, I guess. I'm still not really certain. I'm just talking about what would seem obvious to do. A lot of the rest of these connectors and stuff can just go in here, just to clean stuff up a little bit more. This is a breadboard. I'm just gonna keep it by itself. You might notice that robot already has a breadboard on it. This one just has a proto board. Like I said, I need to solder the Arduino with header pins. I might just use a breadboard for that one too, but that breadboard is too big to even consider it for that purpose, so it's not going to be used. And I'm just going to move aside all this stuff that has no particular purpose being on the floor right now. This is more flat washers, but it has mostly bolts. This I think I will keep with this one, just so it has a box to put hardware in. But the rest of it's mostly with this one. This is actually a bag of transistors. If you recall, a while ago I was trying to make transistor compute computer devices. Here's one. It didn't work, so I'm gonna have to do more work on that. I did make NAND gates, so that's not it. That's a half adder. Because I was trying to make a full adder circuit for a different project, just on its own. Not in relation to these robots. I wouldn't try to make the computer for these robots out of transistors. That would take a while. Speaking of taking a while, this video is 20 minutes long already. So now we can move on to this big robot and all the parts that we'll need for this one. I've basically sorted out a lot of it already, but let's just go over it. So these are Anderson power pole connectors. I'm going to need a lot of them on that robot, so they go there. This is a big spool of wire. It's going to wire the motors. So that already basically takes up half a box. These washers are going to be needed on that robot. So are these nuts. All of these stuff is definitely going to go on there. This is a bag that had a bunch of 3D printed parts in. These are the shaft mounts, so I could replace it with these ones. I'm going to put them back in place. I might have to 3D print more of them, but that's what I'm doing. I'm just organizing everything, and then I'm going to take inventory of what I have and what I need to make. And then we could make stuff. So these are these bars that go across there to hold these two plates in place. Here's another one of these. So this bag is full of 3D printed parts, which are going to go on that robot. And the air can be drained out. Alright, so everything is in there. Also, we have some stuff that's going to go on the robot, like this gear and that piece. The other one of these gears, I still don't think I have a metal part for that one. I need to make that. Maybe I do have it somewhere around here. Also, I have potentiometers in this box right here. I don't think I'm going to put, I don't really know if I should put all of them in this box, but I'm going to put that one. I'm just going to put the ones that I'm going to use. Because this has a lot of unrelated stuff. So I know I'm going to use 2 potentiometers to control the position of these two hips. And we'll just add 2 more. The rest of the stuff, if I need it, I'll just get it from the desk. I think that's good enough. This is just a bunch of garbage, basically. Then we have another one of these cables, which goes in there. And then that's basically all trash. This is one of the hip drive motors. The other one is here. So that's the hip drive motors. Then we have one of those things. And that's everything, all the parts which I currently have for this robot. If I get any more, I'm probably going to have to get another box. Or maybe I should just start using them and putting them on the robot, actually building it. But I don't have time for that. Also, piece of foam for the feet to add cushions to them. It makes a loud noise. And that robot goes there. the parts for the medium robot can go there. Maybe I'll try to make no more screeching noises. This is the top of this robot. This is where the power connector for the Arduino goes. So it was originally powered by 12 volts, so I could just use a USB connector for cars, and then just basically a normal cigarette lighter socket thing, and that would just go in there. And this would go to a 12 volt battery, but since I'm going to power this with 18 volts, this would probably still work. Actually, I think you could connect up to 30 volts directly to the Arduino, but instead of that, I think I'll get a 5 volt regulator. Maybe I'll make one, but and that will work that way. The multimeter does not need to go on the floor and can go there. This little robot barely takes up any space, so it could go there. I'm actually going to do some more work on that soon, though. Oh, also, heat shrink tubing. I am going to use this for wiring the motors on this robot, so that could go there. This is a male connector, so I'm not going to use it. So that basically leaves us with this desk like this. If I want to actually organize this, that's another thing that I have to do. But as far as the robots go, the little robot and everything relating to it is in that box. The medium-sized robot and everything relating to it is in that box. And the large robot, or the walking robot, is spread out across the floor. But all the small parts are in that box, waiting to be assembled. Don't expect any of these robots to be finished anytime soon. I'm going to try this time next year to be getting that one to walk. If nothing, if I continue working on it at the pace I'm working on right now, I think that's reasonable to have walking tests around this time next year. Depending on how much time I get in the summer to work on it, though. It may take more or less time. For this medium robot, or the wheeled robot as it's called on the YouTube videos about it, go watch them. This robot, I already tested it sometime. It's has a lot of issues, mainly with the power distribution from this connector. All the power for the entire robot was flowing through these two wires. I think that was causing issues, plus it was only 12 volts, so it was high amperage because all of these are wired in parallel, all these motors, even though they're going through relays, they're all wired in parallel. So it's all the power going to the motors, all the power going to the coils of the relays. That was just too much. It didn't cause any problems other than the robot didn't work. But I'm going to fix that with fuses and everything. Again, how much time I get in the summer? This was, by the end of this year, this robot should be rolling along just fine. This robot, the small one, might take a few more months, and then this one will be working just fine. Also depending on how much time I get. If I end up with a few days of time, I can finish this all in one day. Like in reality, this will probably take about a few days to work on, maybe. This one will take a few weeks, this one will take a few months. It just, when I get those, that amount of time to work on it is what's being considered. Also, we have to consider if I start other projects, which I am planning to do. Specifically a servo motor focused walking robot, which I want to do before I make this one. Just a little robot with servos that walks along. That robot shouldn't be that more complex than that little one, just because they do sell them in kits. But I don't think I'm going to buy the kit just so I can make it myself. And plus, I already have a bunch of these servos. They're just sitting here. I have 10 of them. I broke one of them, but I still have enough to build a robot with them. I could buy a few more, and then I just need to make the brackets, and that's a servo robot, and that would be ready. There are plenty of experiments I could do with those. I could also put servo motor on that robot for like an arm or something. That would take a while to do, but that would be something that I do after this one is finished. And by finished, I mean it rolls along and it could avoid obstacles like that one will be able to do. Just that's bigger. And then of course I could put an arm on it, and then I could have the Raspberry Pi doing something, which is a good thing for it to do. It could run computer vision software, and then it could look for objects, and then maybe it'll grab a ball or something, and then it'll do something with that. And then this robot will be able to walk. It'll have gyroscopes and things of that sort. And of course, it will also have whatever artificial intelligence that this one and this one have will be on this one, and it will be able to avoid obstacles, maybe like walk around, walk over stuff, that kind of thing. But that is after I'm done testing this one and this one. So that is all of these robots organized together, and see you in the next video.